All right, looks like we've picked up a few people. How many people do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, we're almost a full class now. 14 out of 17, that's not too bad. All right, so let's start on 3.2. Now, if you didn't have enough stuff to memorize, I'm only going to make it worse. All right, so need to know these formulas. These are the sum and difference identities. So these are going to be surprisingly helpful. The cosine of alpha minus beta equals the cosine alpha cosine beta plus the sine of alpha sine of beta. Cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. Now, quick things to remember. If you get a minus, it turns into a plus. If you have a plus, it turns into a minus. Okay, we're talking about the cosine here. So that's kind of your way to remember. You can think of it kind of as cosine. You could distribute your cosine to alpha and beta. You swap the sign to be a plus, and then you do the cosine alpha, or the sine of alpha and beta. Okay. Same thing here. You think of it as distributing. You're not distributing, but this is just a kind of a memory aid here. You're distributing the cosine alpha beta here, then you go with the opposite sign, and then you switch over to the sine of alpha and beta. So that's how you'll remember this one. With your sine of alpha and beta, now this is interesting because the negative follows. So with the sine, you keep the sign the same. So you think of it as distributing the sine of the alpha, except for now we're going with the cosine of beta minus the cosine of alpha times the sine of beta. Okay. It's going to be really important to memorize these. So get some flashcards or something to help you memorize these. Sine of alpha beta, once again, the plus sign follows here, but we're going sine alpha cosine beta plus cosine alpha sine beta. Okay. With the tangent of alpha plus beta is the tangent of alpha plus tangent of beta all over 1 minus tangent alpha tangent beta. So once again, we've got the plus on the top and then a minus on the bottom. Okay. With this one, tangent of alpha minus beta, we'll keep the minus in the numerator and then we switch to a plus in the bottom. So tangent alpha minus beta equals tangent alpha minus tangent beta all over 1 plus tangent alpha tangent beta. Okay. So the nice thing about this is we're going to ask you to use an identity to find the exact value of cosine of 60 minus 45 degrees. Okay. Now you may think of this as, oh, this is really, what is this? This is the cosine of 15 degrees. Well, 15 degrees isn't what I asked you to memorize last time. But I did ask you to memorize 60 and I did ask you to memorize 45. So theoretically, we can use that to find the cosine of 15 degrees without a calculator, okay? So let's see here. Do I want to copy this? I don't know how well this will copy. Make that a little bit bigger. Okay, I'm going to put that over here. Okay. And we're going to use this to find this value here. So we're going to test you guys and see. First of all, let's see, we started at the bottom of the class yesterday. Let's start at the top. How about, is it Brian Larson's turn? I think it is. Brian Larson, so which of these 6 identities would you think would be most helpful? 1, 2, 3, 4, 5, or 6?
Oops, sorry. Mic was on mic or mute. Sorry. It would be the first one, would not.
The first one, right? Okay, so using 60 and 45 as alpha and beta, tell me what to write here.
So cosine of 60 degrees is
Well, just tell me what to write first, and then we'll figure out the letters later. Okay. So
Okay.
cosine of 60.
Minus the cosine of 45. Or sorry, plus. Yeah.
Times.
I'm reading the wrong part. Yeah. Times the cosine of 45.
Okay.
Plus the
Plus
sine of 60 times the sine of 45.
Now we're going to test your memory to make sure you know those. So the cosine of 60 is what?
The cosine of 60 would be the square root of 3 over 2.
Isn't it 1/2?
It could be. I always get them confused because one is the x and one is the y.
Yeah, see, sine goes 0. Sine starts at 0, so cosine's always backwards. That's how I remember it.
Yeah.
So that's 1/2, right?
Yeah.
Okay. Cosine 45
is the square root of 2 over 2.
Square root of 2 over 2. Okay. Plus sine of 60.
Then the sine of 60 would then be the square root of 3 over 2.
And the sine of 45
is the square root of 2 over 2.
Okay. So let's simplify this fraction here. And what do we got?
So I guess it would be, you just go straight across, right? So it'd be the square root of 2 over 4.
Okay. Plus.
Plus, it'd be the square root of 3 times the square root of 2.
Which is?
I guess the square root of 6, right?
Mm-hmm.
Okay.
Over
4.
Okay. So we've got a common denominator. So we're going to get something over 4, right? So what's the something over the 4?
It would be the square root of 2 plus the square root of 6.
Square root of 2 plus the square root of 6. Okay. And let's make sure, but that's exactly right there. Okay. So now I can ask you to do the cosine of 15 degrees, and you'll know that it's the square root of 2 plus the square root of 6 over 4. No memorization needed, right? Okay.
Why wouldn't you just add those together?
Let me ask you something. Why, yeah, because that's bad math. Are you saying the square root of 8?
I think that's what he's meaning.
Yeah, that's bad math. You can multiply square root of 3 times the square root of 2. You can multiply those together to get the square root of 6. But you can't add square root of 2 plus the square root of 6 is the square root of 2 plus the square root of 6. You don't add those. Okay. All right, let's move on to the next one here. Now, let's talk about cofunctions. Let's see, do I have? Oh, well, before I show you that, I've got some more stuff for you to memorize here. Okay, so this is a special, actually, I'm going to copy this. This is called cofunctions. Okay, it's related to what I've already got here. Okay, any pair of trig functions f and g for which f of x equals 90 minus x and g of x equals the function of 90 minus x, those are called cofunctions. Okay, So we want to verify that the sine and the cosine are cofunctions of the cosine of alpha minus beta. Okay. So essentially, make sure I'm doing this right. Yeah. So let's do this here. Let's find the cosine of 90 degrees minus beta. Okay. So we're going to use these same sum and difference identities. So this time, it must be Brody's turn. Okay. So which of these 6 functions do you think would be helpful with this equation here?
Would we use the first one again?
First one again. Okay. So plug in the first one here and tell me what to write.
You're going to have cosine of 90 times cosine of beta.
I'll put B for beta. Okay.
Plus sine of 90 degrees times sine of beta.
Okay. All right, now, what is the cosine of 90 degrees?
0.
0, so that's going to wipe out this whole thing, right?
Right.
0 plus, what's the sine of 90 degrees?
That's just 1.
1, so therefore, this becomes the sine of beta.
Of beta, yeah.
Yeah, beta, beta, yeah, beta. So what this shows you here is the cosine of 90 minus beta equals the sine of beta. And so we refer to this as a cofunction. Okay, so that's kind of useful. Now we're going to do the same thing this time with, here, I'll just copy this because it's here. The cosine, we're going to show, we're going to do the same thing with the sine. We're going to show that this, what happened? Sine of 90 minus beta. Okay, so that was Brody. Cameron Daly, it must be your turn.
All right.
Here's what I'm going to show. We're going to show that this is the cosine of beta. Okay, we'll make this kind of an identity, but use these 6 rules here.
So we'd use the third one down.
Okay.
So we do sine of 90 times the cosine of b or beta.
Beta, yep.
And then minus the cosine of 90 times the sine of beta.
Okay. What's the sine of 90?
So the sine of 90 is 1.
Okay. So this would just be leave us with the cosine of beta, right?
Right.
Okay. Minus.
What's cosine of, oh, sorry. Cosine of 90 is 0.
0. Okay. So we just verified that, right? Okay. So that's called the cofunction. So the cosine of 90 minus beta is the sine. The sine of 90 minus beta is the cosine. Okay. And okay, so we've just proved these first 2 right here. So these are some more identities that you're going to want to memorize. Okay. Now, tangent and cotangent are cofunctions as well. Let's do that as an example here. So let's have, that was Cameron. Cassie, where's Cassie? Are you on camera, Cassie?
I'm not, just because of bandwidth issues.
Oh, that's why. Okay. So Cassie, can you utilize some of these to help me out here?
I'm not sure, to be honest.
Okay, so we've got a tangent and we've got a minus in here. So which one of these deals with tangents and a minus?
The last one.
The last one. Okay. So we're going to use this last one here, and so alpha is going to represent your 90, and beta is going to represent your theta. I don't know why I used theta. Well, the book used theta because they want you to get used to Greek letters. But let's change that theta to an x when we do this because I can't do a theta. Okay. So tell me what to type on this formula here.
So it'll be tangent 90 minus beta, or alpha,
Tangent.
or x, sorry.
X. Or we could call it beta. Let's call it beta, that's fine. Okay. Over, so this is a fraction. Oh, I covered it up. Actually, I want to use that one. Okay. Over 1 plus
1 plus the tangent of 90
tangent of 90
times the tangent of beta.
Of beta. Okay, so do you remember what the tangent of 90 is?
Tangent of 90 is undefined.
Is it? That doesn't help. It's not undefined, is it? Oh, you're right, it is. So we shouldn't be using that. Yeah, we don't want to use that one. I changed my mind. Okay, that doesn't help us, does it? Okay, so let's try this again. This time, let's write it as the sine of 90 minus beta over the cosine of 90 minus beta. We know that the tangent is the sine over the cosine, right?
Yeah.
Okay. Now, let's use one of these again. So we don't want to use that one because that didn't help us out. But, so what's the sine? Or which one of these would we use?
So we would use the third one.
Third one, okay. So this becomes what?
So the sine of 90 would be
Well, don't worry
1.
about that yet.
Oh.
Okay.
Sorry.
Yeah, we'll get to that. Okay. So we're using this one. So sine of 90
minus beta.
cosine of beta. Right? We're using this one
Yeah.
here.
Yeah.
Okay.
Minus the cosine of 90
Okay.
times the sin of
Sine
beta.
of beta. Okay. All right, so we've got the numerator, and now let's get the denominator.
So the sin of 90 is 1.
Of 90. Yep. No, we don't want to use that. We're using cosine now.
Oh.
So we're using this one.
Oh. So cosine of 90 and the cosine of beta plus the sin of 90.
Sine of 90. We don't believe in sin in this class. They're sines.
And sine of
This is
beta.
Sine of beta. Okay. All right. So we've got our fractions here.
Why is it sine of 90 and sine of beta? Why shouldn't it be? Let's see. Shouldn't it be like?
So the numerator is using equation 3. The denominator is using equation 1.
Okay, so the equation 3 would be cosine. Okay.
So sine, cosine, cosine, sine.
I see it.
Yeah.
Gotcha.
Okay. All right. So now Cassie's been wanting to tell us that the sine of 90 is 1, right?
Yeah.
So we've got cosine of beta on the top, right? Minus what?
Would be nothing. Sine of beta.
Cosine of 90 is 0, right?
Yeah.
Okay, so minus 0 essentially. Okay, and then the cosine of 90 is
0.
still 0. We're going to add, oops. The sine of 90 is
1.
1 times the sine of beta.
Sine
Okay, so essentially here we've got the cosine of beta over the sine of beta. And what does that equal?
The tangent of 90.
Not the tangent.
Oh.
Remember, tangent sine over cosine.
Oh, the cotangent.
Cotangent of beta. Bam. Okay. So we just proved that this is a cofunction with the cotangent of, they've got theta there. Here, I'll put theta because I hate to spell out theta. But anyway, we just proved that cotangent. That's a cofunction, I mean. Okay. So once again, don't you feel smart, Cassie?
Yep.
You just proved that you just proved this, okay? So the cofunction identities: 90 minus theta is the cosine. Cosine of 90 minus theta is the sine. Tangent of 90 minus theta is the cotangent. Cotangent of 90 minus theta is the tangent. Secant of 90 minus theta is the cosecant. Cosecant of 90 minus theta is the secant. So, of course, instead of putting the 90s in there, you can use pi halves. So we just proved. Okay, so you've got the 6 cofunction identities to go with your 6 sum and difference identities. So you'll definitely want to memorize that. So all right, let's move on here. Okay. Maybe we'll do this if I have time. I want to make sure we get through everything. Okay, so this is okay, so now we're going to, maybe I'll open up a new sheet here. We want to write each expression as a trig function. I'm going to copy this here so that we can see it still, because I know you guys don't have it memorized yet, but you'll have it memorized by tomorrow, right? Okay, so basically, whose turn is it to pick on now? That was Cassie. Chris Hardwick, it's your turn. How come you're still a guest? You're welcome in this class anytime. You don't need to be a guest.
Thank you.
All right. Yeah, you just didn't log into Teams. That's why it does that. Okay, so
Yeah.
how could you simplify this using one of these identities, and which one would you use?
Let's see. All right, so that would be the third.
The third one, right?
Sine of
Okay.
A minus alpha minus beta.
Okay, so this would be what?
So I can't hear you. What?
Oh, go ahead and keep going.
So it'd be you want what do you want? I can't understand you.
I want you to simplify this expression using one of these.
Okay. Let's see. Sine of 5x. I have no idea how to do that.
Okay, so let's talk about this for a second. So alpha, in this case, is going to equal 5x, and beta is going to equal 3x. Okay?
Mm-hmm.
So you told me already that we were using rule 3, right? Rule 3 was Maybe I won't. I'm going to call this A and B, right? A and B, because that's going to be easier.
Yeah.
The sine of A minus B. Told me we were using rule number 3, right?
Yeah.
Equals sine alpha cosine beta minus cosine sine beta. Okay. So all we're doing is we're using this in reverse. Okay. You've already got this. You've got the right side. We want to go to the left side.
Okay.
So
it'll just be sine of 5x
5x
minus 3x.
3x. And you could probably simplify that further, and that would be what?
And that'd be 2x.
Sine of 2x. Okay. Piece of cake?
Yeah, I didn't know that's what you wanted.
Yeah. Okay. All right. So let me just mention this here. Okay. Right now you're doing all these things and you're saying, why are we going to do this? And the reason why is because later on in the class, I'm going to set something like this equal to, say, 1 or something. And then you're going to be like, oh, sine of 2x equals 1. And then you're going to do an inverse sine and figure out what that is. Okay. So these exercises may seem pointless now, but they will not be pointless later. Okay. All right. Let's do another one here. Okay, I want to write this one. Let's see how well this copies.
I'm on. Is it okay if I get a cup of water?
Yeah, go get some water. That's fine.
Okay.
Okay. All right. So tangent of 4 alpha plus the tangent of alpha over 1 minus 4 tangent alpha. Tangent alpha. I want to also write this as a single trig function. Okay. So whose turn is it now? That was Chris's turn. Corey, it must be your turn. Corey, you're not sitting in your car today.
No, I don't have to go into work till noon today. So
wow, lucky you. It's good to see you not in your car. So, yeah, which one of these would you use?
So we're going to use the tangent of, it's square root plus 8. So the tangent of alpha plus beta.
Right. Okay. So how would you simplify this?
So we know that tangent of alpha is 4a, and we know that the tangent of beta is a, or sorry, tangent of beta is a. So you would just do tangent of 4a plus a, which would give you the tangent of 5a.
Equals the tangent of 5a. Wasn't that nice? Okay. Because probably if we set this equal to, say, 1, you'd probably be like, oh, yuck, that's an awful problem. But then you'd be like, oh, yeah, tangent of 5a equals 1. Oh, not 1, maybe 0. Set it equal to 0, right? Because we can do that. And then that would be easy to solve, right? So that's why these identities are very cool and important, okay? Because you can take something nasty like this and turn it into something simple, okay? All right, so let's see, let's try this one. Okay, do I have enough room? Let's try this here. Okay, so given the tangent of alpha equals -4/3 for alpha in quadrant 2, and tangent of beta is negative 5/12 for beta in quadrant 4, find the sine of alpha plus beta. Okay. So Corey's going, boy, I'm glad I got that easy one and I'm off the hook. Graham, you're up. What do you think?
Oh man, I'm toast.
Yeah, this is a tough one, huh? You're going,
So-
why did you pick on me?
So is that negative 4/3? Is that like the slope of a line or something like that? Or is it a point?
Well,
or
it's
is it
talking about
just
quadrant
a
2.
value?
So first thing we will probably want to do is start drawing our axes here. Okay, so we're in quadrant 2, right?
Yep.
Okay, so we're in quadrant 2. We've got some sort of an angle here. We're going to call this alpha. Okay, so this is some sort of an alpha, angle alpha. Okay. Now we know that the tangent of alpha, tangent alpha, equals negative 4 divided by 3. Now remind me again, because maybe I forgot, what is the definition of the tangent when we're talking about? Do you remember?
Is it y over x? Is that what you're?
Y over x, that's what I was looking for.
Okay.
Okay. So if tangent is y over x, then, well, the question is, it could be that y equals negative 4 and x equals 3, or it could be y equals 4 and x equals negative 3. Which of those, oops, that's supposed to say 4. Which of those two is more likely correct the way I've drawn my picture here?
The first one, y equals negative 4, x equals 3.
Yes. Okay. So essentially what we can do now that we've got our picture here, we know that y is negative 4. No.
Yeah, that's x equals negative 4 because you're drawing a line on the x-axis. Right?
So it's the second equation.
We said we're in quadrant 2, right? We're in quadrant 2, Q2.
Yeah, so sine is positive. Y is positive. And x is negative.
Correct.
Yeah, sorry, I said the wrong one.
Okay. All right. So this is negative 3, and this here number is 4 right here. So that's 4. Okay, so we can get rid of the top one. Okay, so that's what we've got going on. Okay. All right, now let's go back to here. We've got the tangent of beta equals negative 5/12 for beta, and we're in quadrant 4. Okay, so we're in quadrant 4 here. I'll draw a different size angle here. It could be over here or here, I don't know, but for now I'll just draw it there. I don't know. I just don't want it to look like a diagonal line, basically. Okay, so we're going to call that, maybe I'll put that over here. So that angle there is beta. Okay, we know that the tangent of beta is negative 5/12. So tangent of beta equals negative 5/12. Okay, so we picked on Graham. Graham, I'm not going to let you off the hook, but I am going to let you off the hook for a second here. We're going to tag team with Jackson. Jackson, are you on camera?
Yeah.
You are on camera? How come I don't see you?
Well, I don't know.
Oh, that's weird. Okay, so so do the same thing we did here. So tangent we know is y over x, right?
Yep.
So the question is, what should your coordinates be? Is y negative 5 or is y positive 5 in this?
Y is negative 5 because we went down from the x-axis.
Equals negative 5. and x equals
12.
12. So I probably should have drawn it the other way, but that's well. Should we fix our drawing? Yeah, we probably should. It'll look better. Oh, I erased that amazingly well. I usually don't do that good. Ooh, I didn't mean to draw a triangle there.
No, wasn't it right the first way? It would extend more along the x-axis than the y-axis.
Oh, you're right. I did have it right the first way. Let's leave it alone. Okay, never mind. Okay, so x is 12 here. And y is a -5. Okay, so now we need to find the sine of alpha plus beta. Find the sine of alpha plus beta. Okay, so we've at least got it drawn correctly. Okay. So let's think about this for a second. So if this is 3 and 4, do you guys know what the length of the hypotenuse is without doing any hard work?
Five.
25?
Yes,
5?
it's 5, right? So that's a 3, 4, 5 triangle, right? Okay, so then what about, you guys might not know this one, but this is do you guys know the length of the hypotenuse here?
Is it 13?
Oh, I'm proud of you. Who said that? Nicole. I'm very proud of you. It's a 5, 12, 13 triangle, right? So that was very nice that we have those there, okay? All right, so now let's talk about this for a second. Okay, so sine of alpha plus beta, okay? So we'll worry about the signs here in a minute. Okay, so so do you guys have those memorized yet? Sine of alpha plus beta, that's the one we're gonna use, right? Well, maybe we've got it to here. Okay, let's start putting some stuff. So we know need both things here at the same time. We're trying to find sine of alpha plus beta. Okay, so we know that that's basically, we're going to be using this one here, right? Rule number 4. Okay, so what we're going to need to do is we're going to have to figure out all the sines and cosines. Okay. Now, so what's the sine of alpha? Here, let's do this first. Let's worry about this one here. What's the sine of alpha in quadrant 2?
4.
It can't be 4. Your sine always has to be less than 1, but there might be a 4 as part of the answer. Remind me again. So if tangent is y over x, what's the sine?
It's 4/5.
Sine is it
y over r?
Y over r, right? Okay. All right. So if sine is y over r, so sine in this case is going to be what? Sine of alpha is going to be what?
4/5.
4/5. And we remember that all students take calculus. So is this 4/5 positive or negative?
Positive.
It's positive, okay? All right, so we know that the sine of alpha is 4/5, okay? Let's get the cosine of alpha just because we might need it later. Cosine, remind me again, is what?
X over R.
X over R. So in this case, it's going to be what?
Negative 3/5.
Negative 3/5. Okay, is everybody on board with that? Any questions on that? Okay. All right, let's move on to the tangent of beta is negative 5/12. So we know the sine of beta is going to be what? Whose turn is it now? Josue, it must be your turn. Where's Josue? Oh, there you are. Except for you're on mute, I think. I can't hear you.
Yeah, okay. Sine of beta is...
So that's going to be y over r, right?
Yeah.
Which is going to equal what?
Which is negative 5/13.
And is it negative in quadrant 4?
Yeah.
Yep. Okay. Well done. And let's get the cosine of beta while we're at it. So that was Josue. Ivan, it's your turn. Are you back from getting your drink? Are you on mute? Ivan, you're still on mute. So that's going to be x over r, right?
No, sorry. It was giving me a, we didn't want to click the unmute button, sorry.
Okay.
So what was the question?
So what's the cosine of beta?
To be honest, I'm waiting to see the whole problem so I can write it out because I'm a little confused.
Okay, so I've got my picture here. This is my angle beta here. We've got a 5, 12, 13 triangle. Cosine equals x over r. So what's your x in this case?
12.
12. And what's your r in this case?
12. Is it?
R is your hypotenuse.
Oh, sorry. 13.
13. And is the cosine positive or negative in quadrant 4?
Negative.
No, remember, it's positive. All students take calculus. Right? Okay, so here's what we're going to do. I'm going to copy this here. We've got that here. We're going to copy this over to here. And I want to copy it clear over there. Put this, we're going to keep this here, and then we're also going to copy this. And we're going to copy this. So I like this. This is one problem, and I've had all these people helping me with this. All right, so we've got all this information now. So remind me again. Let's see, that was Ivan. Mason, it's your turn. Sine of alpha plus beta equals what, according to these sum and difference identities?
That would be the second one. So it'd be cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Oh,
it was the
I'm looking at the wrong
fourth
one.
one.
Look at the fourth
Yeah.
one. Yep.
Okay, so sine of alpha. Say it again.
Sine of alpha times the cosine of beta.
Cosine of beta.
Plus the cosine of alpha.
Cosine of alpha.
Times the sine of beta.
Okay. So in this case, the sine of alpha is what?
4/5
4/5. The cosine of beta
is 12/13.
12/13. We're going to add that to
negative 3/5.
negative 3/5 and
negative 5/13.
negative 5/13. Okay. So now 4 times 12 is 48. 5 times 13 is 65 plus negative 3 times negative 5 is 15 over 5 times 13, which is 65. So the sine of alpha plus beta equals 48 plus 15 divided by 65. Divided by, okay, slash, parentheses, slash 65. Okay? So if this were a quiz question, rather than give me the decimal, which is whatever it is, 63 divided by 65, I would rather you gave me 63/65 rather than 0.969. Does that make sense? Okay. That was a good one. Holy cow, maybe I better move a little bit faster. I want to make sure we cover all this. So, all right, so there we are. There's your everything that we just did. What more do we have here? Oh, we've only got a half a page, but we'll go this a little bit faster. Verify the identity cosine of pi minus theta equals the negative cosine of theta. Okay, so we're going to use the alpha cosine of alpha minus beta identity to show this. Here, actually, I do want to. I think it's good for you guys to work through these because you guys need practice. I'm going to we'll try to go a little faster here. Here's what we'll do. We'll go a little bit faster though. So the cosine, so we're verifying the identity cosine of pi minus theta equals the negative cosine of theta. That's going to be this one here, the first one. Okay. So that's going to be the cosine of pi times the cosine of, I'm going to put beta instead of theta because I can't make a theta, plus the cosine, excuse me, the sine of pi times the sine of theta or beta. Okay, so I will ask this question because I do want to keep you guys still involved here. That was Mason. So Nicole, it's your turn. We're going to practice you on your what's the cosine of pi?
Is that 1? 0. Shoot.
Shoot.
You should have asked me the questions before I knew those answers. Isn't it?
So,
or no, it's -1.
It's -1.
-1.
-1 times, so the cosine of beta. I'll just do it right there. What's the sine of pi?
0.
0. So you just verified that that is that. So the cosine of pi minus theta is the negative cosine of pi of beta. So, whatever the letter. Theta. Okay. You guys. So the best thing about this class, usually I make the joke long before now. If it looks Greek to you, it probably is. But we're going to learn a lot of Greek letters in the alphabet. Okay. So thank you, Nicole, for helping me to verify that identity. Okay. Let's do another one here. verify the identity. Well, I guess we've got 2 more left. Okay. Verify this identity. We're going to open up a new page. Whoa, that's big. And okay. So verify the identity. Cosine of 4 theta over sine of theta minus the sine of 4 theta over the cosine of theta equals the cosine of 5 theta over sine cosine theta. Okay. So that was Nicole. Tate, what do you think you would do first?
I'm not sure.
Okay.
Because it doesn't look like any of the identities quite yet.
Quite yet, that's correct. But you've got 2 unlike denominators. What would you normally do on the left side?
I guess we could make a common denominator by multiplying.
So we'd have to multiply by what over here?
Cosine over cosine.
Cosine of theta.
Cosine of theta over cosine of theta.
I'm going to put T for theta over the cosine of theta. And on this one here, we'd multiply by
the sine of theta.
Sine of theta over the sine of theta. Okay. So now we've got a nice common denominator of cosine, sine of theta, cosine of theta. So that's my common denominator. On the top, I've got what?
Cosine squared.
No, we can't square them because they're different angles. So I've got the cosine of theta.
Cosine of theta times cosine
of 4 theta.
4 theta.
Okay. Minus.
And the sine of theta times the sine of 4 theta.
4 theta. Okay. All right. So here's the cool thing. My denominator on the left side is now the same as the denominator on the right side. So at this point, all we have to prove is that whatever we've got here equals the cosine of 5 theta. Can we do that?
That looks like the second equation. So it'll be the cosine, well, let's see. A would be, or alpha would be theta and beta would be 4 theta?
Correct. So then we can add them together, right? So theta plus 4 theta equals?
Is 5 theta.
Theta. Boom. See, these aren't too bad, right? You want 10 of these on the next test, right? Right. Okay, so last one here. This is the last one. We got 4 minutes left. Write as a function using only the sine of theta. The sine of theta plus 2k plus 1 pi, where k is an integer. This one's going to be a little bit tough, and plus we've only got 3 minutes left. So I'm gonna read my notes here, so to make you guys struggle through them. So we're going to use the sine of alpha plus beta identity. So in this case, we're gonna treat this as your alpha. We're going to treat this as your beta. This whole big thing. Okay. So that gives us the sine of theta times the cosine of the whole big chunk. Plus the cosine of theta times the sine. You know, I don't think that's supposed to be in there. So if k is an integer, the 2k plus 1 is an odd integer. And the odd so cosine of odd multiples of pi's are -1. So essentially what I've got here is I've got the sine of theta times -1, because all of this, excuse me, all of this is going to be -1. And this should not be here. And this should not be here either. Okay. So so I've got the sine of theta times -1 plus the cosine of theta, and then the sine of any negative multiples of pi, of any odd multiples of pi are 0. So this term is going to completely drop out. And so therefore, all we have left is the sine of theta. Okay. So sine of any multiple of theta plus pi is going to be the negative sine of pi. Does that make sense? Okay. For anybody, but hopefully that does. So the funny thing is, Tayton, did I pick on you yesterday? The only person I didn't pick on today was Texas. Texas, you got off the hook today.
Yay.
All right. So any questions you guys have for me?
I had a question.
Okay, go ahead.
So can we make a sum difference identity for cotangent by just inversing the fraction for the tangent?
Oh, so the cotangent. Let me think about that. I don't. Gotta be careful with that kind of stuff. I'm gonna say no. Well, that's a good question. That might be a homework question. My first inclination would be to be careful, and I would say no. But yeah, I would be careful of that.
Okay.
I get possibly that's true, but I would have to verify that first, and I haven't thought about that enough. So, but in summary, the takeaways from today's lesson is you've got to memorize your sum and difference identities, and you should also do the cofunction identities. So, those cofunctions aren't too bad. So those are the takeaways from today's lecture. Especially, I think by now you can see how important the sum and difference identities are. So, all right. Well, I know we're out of time, but I'm proud of you all for coming and most of you being on camera. Quiz on Wednesday is going to be on 3.2. Homework 3.2, and I'm really glad that everybody has a book by now. Okay? And I'm going to try very hard, Nicole, to update those quizzes. I only did the attendance yesterday, but at least I got the attendance, huh, Nicole?
Yeah, good job.
All right. Okay, so, all right. Well, we'll see you guys all tomorrow, and if you want to stick around and Texas, is that like just a standing study thing after class?
Yeah, I think so.
Okay. So stick around with Texas and study hard, and I'll start working on your quiz. All right. Well, we'll see you guys later.
And see ya.
Thank you.
Mm-hmm.